Okay, so let's see if we can prove this statement here then. Remember, this is how it gets restated, and the way we're going to try to come up with a proof is to start with this and see if we can kind of work our way back to that, but ultimately state it in this direction. Alright, so let's see how that works. We'll take the expression there, we'll take the inequality there, write it all out and see what we can do with that. Well, it simplifies down to this. Oops, there's an X there. It simplifies down to this. And the expression here on the left actually factors. So it factors into, let's see, an x minus 3 and an x plus 1. And actually that's starting to look a little bit promising because remember, we were trying to get our way back to something that looks like this with an x minus 3 absolute value in it. And lo and behold, here it is. Here's that x minus 3 absolute value. Well, there's this little extra bit there that's causing some trouble here because I don't really want that there. What I have to do is kind of estimate its size and say how big it would be. And here's how we can work with that. Well, if x is approaching 3, I think it's safe to say that x getting close to 3 means it would have to be in between 2 and 4 then. If it's close to 3, it's got to be between 2 and 4, right? And so let's see if we can work with that a little bit. If x is between 2 and 4, what can we say about this x minus 1 expression that's kind of left over there? Well, let's do a little arithmetic here. That means that x plus 1 would be between 3 and 5. All right. Well, it's the absolute value of x plus 1 that I'm concerned with. And if you compare the 3 and the 5 here, I guess what we can say then is that the absolute value of x plus 1 is less than 5. All right. How can I use that? Well, let's see. If I could say that x plus 1 is less than 5, maybe I can just kind of replace this with the number 5 then. Let me write that over here. So if x minus 3 plus x plus 1 is less than x minus 3 times 5, well, if I could get that to be less than epsilon, then I'd basically have the thing that I wanted, right? I could get that this thing is less than epsilon. Well, let's take a look at this. This says that x minus 3 is less than epsilon over 5. And I think we kind of are figuring out how to start with something like this and end with something like this now. If I just start with this inequality, I'll get there. Well, it's a little bit fussy though because of this, and I think we really should pay attention to that and not gloss over that too much, because we indeed are trying to show that for every epsilon greater than 0, there's a delta greater than 0, so that as long as this statement is true, this must be true, not for just our favorite values of x's, but for every value of x that makes that true, even including the x's that might be out of these bounds. So we really have to be careful with our logic here. Well, here's what we're kind of realizing we're saying now about this expression x minus 3. What we really would like to have, and remember working our way backwards, is two things. I'd like to be able to say that x minus 3 is less than epsilon over 5. And I really would like to be able to say that x minus 3 is less than 1, because that's actually the same as saying that x is between 2 and 4, isn't it? X minus 3 less than 1 in absolute value means that x is no more than 1 unit away from 3. It would have to be between 2 and 4. So if I could get both of those things to be true, then this inequality here can in fact be used, and I think my logic works backwards okay. Well, the only way to get x minus 3 to be less than two different numbers is to kind of insist that x minus 3 be less than, well, whichever one of those numbers is smaller. So let's say it's the minimum of epsilon over 5 and 1. That looks like the delta expression that we need to use here. That's a little fussy looking, but I think it's going to work. If we say that x minus 3 is less than that expression, I think with all this scribbled out notes here, I think we kind of have a proof here, but we need to write it down in the proper logical order.